The next concept what we are going to study today is called as search techniques for graph. So already we have studied the basic definition and the different types of graphs. Okay, graph is what? It is a collection of vertices and edges, which is represented as G of VE, where V and E represents the number of vertices and E represent the number of edges. Okay, so the search technique for the graph, what it indicates is that, as per the definition, the search technique for a graph determines there exist whether there exists a path there exists a path in the given graph such that the path starts at vertex u and ends at vertex u. So what basically the search technique is in the graph is that we have to start from one particular vertex in the graph and start exploring the graph. So exploring the graph means here, if we start at one particular vertex, say in this particular example here, 1, so I have to start finding out its neighboring or its adjacent vertices. Okay, the adjacent vertices here, it could be what? It is what? So the next 2 and 3 I have to start exploring next time onwards. So it is just a process of searching each and every vertices, and we have to ensure that there must exist a path between those two vertices. So in the search techniques, we have basically two different techniques. The first technique is called as the breadth first search, and the second one is called as depth first search. The term indicates the breadth means we have to search the breadth wise first. Okay, so then the second one is depth, indicates we have to go in depth first and then we can proceed in the further steps. Let us try to understand what actually these breadth first search, in short term we call it as BFS, and depth first search as DFS. Okay, so today we will start with the breadth first search. Okay, let us take the example and try to understand what actually this breadth first search is. Now here, okay, to understand this what breadth first search is, that I have taken a simple graph here. Okay, what is graph? This graph contains how many vertices? It contains total 5 vertices, and there are how many edges? There are total 5 edges. Okay, now in this particular context, breadth first search, we encounter certain terms. The first term is visited vertex. Second term is explored vertex. Third term is unexplored vertex. And the fourth term is Q. Okay, so now let us see what this Q is. Q is something, it is nothing but it is a data structure, which I think you have studied in your second semester. Q data structure. What is the feature of the Q data structure? The insertion takes place at one end called as the rear, and the deletion takes place at the other end called as the front. So we make use of the Q data structure in order to do the breadth first search in a given graph. Okay, then the next remaining terms are visited vertex. So visited vertex, in the sense, in order to search in a given graph, we will encounter a particular node or a vertex. Probably here that the term is vertex. Suppose in order to search any of the vertex, in during the search I may encounter certain vertices. So those vertices are called as visited vertex. Suppose if I start from the vertex 1, then this one is called as visited vertex. Okay, then while visiting to the next vertex, what I need to do is that I need to explore this particular vertex 1. Okay, explore in the sense I need to find out its adjacent vertices. So for this vertex 1, adjacent vertices are what? 2 and 3. So for this 2 and 3, I need to visit. Now you need to pay attention to the words what I am using here. In order to explore vertex 1, I should visit its adjacent vertices, which are vertex 2 and vertex 3. That is, in order to explore vertex 1, I need to visit what? 2 and 3. If I visit all the vertices which are adjacent to vertex 1, then I can call this one as explored vertex. Any vertex can be called as an explored vertex only if all its adjacent vertices are visited. Then I can call this one as the explored. If suppose now I will be visiting, now after 1 I visit 2 and 3, then I can call 1 as the explored. So I have explored it. So there is nothing, no more paths exist from 1. Okay, the only path exists is 1 to 2 and 1 to 3. So I explored 1. Now what are the new vertices which I have visited now? Those are 2 and 3. So now these 2 and 3 are visited. They are not explored as of now. Only these two will be explored when I visit the neighboring or adjacent vertices associated to each of them. For example, if I want to explore vertex 2, what I should be doing? I should be visiting all its neighboring or its adjacent vertices. So what are the adjacent vertices to 2? It is 1, which is already explored. Then the remaining 2 are 4 and 5. So if I visit 4 and 5, then I can say 2 is also explored, because I would be visiting all the vertices which are adjacent to this particular vertex 2. So now we may find that the new vertices which are visited here, the new vertices are what? 4 and 5. So now these two are newly visited, but these are not explored. These are still unexplored. Only this will become explored when we visit the neighboring vertices of these. Then we can say these vertices are also explored. So the terms here are visited vertex. If we visit any one particular vertex, then we can call it as the visited vertex. Second one is explored. Explored in the sense, if we visit all the adjacent vertices of a given vertex, then we can call that given vertex as explored vertex. If it is not explored, means if all the adjacent vertices are not explored or not visited, then we can call it as unexplored vertex. These are the terms which we will be using in order to understand what is breadth first search. Is this particular terminology is understood first? If there are any doubts, you may just unmute yourself and ask questions. Okay, fine. We'll proceed further now. Okay, now in order to understand what breadth first search is, there are certain steps that we need to take care. Okay, so let me explain those things with a diagram here. Okay, let us take this particular diagram or this particular graph, wherein we have these many vertices and the associated edges with this. So what we need to do here is that we need to find out BFS, that is first search. Okay, now what we can do is that we can pick any of the vertex as the beginning. I can start from 1, I can start from 2, or even I can start from 8. So what I will do is that I will first choose 1 as the initial vertex. Okay, initial vertex in the sense, now I will be visiting vertex 1 at the beginning. Okay, so since I am visiting this particular vertex 1, I will write that 1 in the BFS search, that I am visiting 1 at the first. Okay, then at the same time, I will make use of one queue. Now this queue is what? It is a queue data structure, wherein the insertion takes place at the rear end and deletion takes place at the front end. Means I believe that you know the concept of queue here. Okay, now since 1 I am visiting, so it is still not explored, it is still unexplored. So what I will do is that all the unexplored vertices I will keep on adding into my queue. So at this point, I have started with the vertex 1. So in the BFS, I will add it as first one as the 1. And at the same time, I will add this 1 into my queue because this 1 is not yet explored. It is just visited. It's still unexplored. Okay. Then in the breadth first, what I should do is that I should find out the adjacent vertices of this 1. Okay, what I want to do is that I want to now explore this vertex 1. In order to explore the vertex 1, I need to find out the adjacent vertices. So adjacent vertices for 1 are what? 2 and 3. So what I will do is that I will visit 2. Okay, so that 2 I will mention in my BFS search, and at the same time I will add this 2 into my queue as well, because queue is not explored, just it is still an unexplored. And at the same time 1 is also connected to 3, so now I will visit this 3 as well. So 3 also I will add it over there, and at the same time I will add it into my BFS also. Okay, now at this stage what we need to understand here is that I started from 1 and I wanted to explore this, so I visited 2 and I visited 3. So as soon as I visit 2 and 3, then this particular vertex 1 becomes an explored vertex. Means whatever possible search I can do from 1, that is 1 to 2 and 1 to 3 are done here. So from the queue, I need to delete now. Which one I will be deleting? I should be deleting the one which has entered first, that is 1. Since now 1 is explored, I will remove from queue here. Okay, now so at this stage, the vertex 1 is explored and newly visited vertices are what? 2 and 3. Now you may see here 2 and 3 are here. Now among these 2 and 3, which one should be I exploring first? The concept is queue. The first come, first serve. The first one, the one among these two, which one is the one which is entered first? That is vertex 2. So first I should be exploring 2. In order to explore 2, what is the basic rule? I need to find out the adjacent vertices from this particular vertex 2. What are the adjacent vertices? 1 is one vertex, 4 is second, and 5 is the third one. Among these 3, 1 is already explored. 1 is already explored, so no need to bother about this one. So what are the other 2 I will be looking into? I should be looking into the vertex 4 and vertex 5. So from 2, I will choose 2, 4. So I will enter that 4 into my BFS, as well as I will add it to my queue as well. Okay, then what is the left out from 2? That is the vertex 5. That 5 also I will add into my BFS and I will add it to my queue. Now at this stage I need to find out, are there any more vertices which are adjacent to vertex 2? No, there are no adjacent vertex from 2 other than 1, 4 and 5. Now I have to ask the question whether I have visited all these 3 vertices. Yes, 1 was already explored. Now 4 and 5th I have visited now. That indicates what? This 2 is also now explored because I have visited all its adjacent vertices. So since 2 is explored, what I should be doing? I should be removing it from queue now. So I should be removing it from queue. So what are the elements left out in queue? 3, 4 and 5. Among these 3 vertices, which one I should explore? The one which has entered first. Among these 3, the one which is entered first is 3. So this vertex 3 I should be exploring now. So now I need to again find out what are the different vertices which are adjacent to 3. From 3, where adjacent are the vertex 1, the vertex 6 and the vertex 7. Among these 3, 1 is already explored, so I will exclude this one. Then what are the remaining? 6 and 7. So what I will do is that I will consider 6 first. So I will add it into my BFS as a 6. Then what is left? At the same time, I will insert this 6 into my queue. Then the next is 7. That 7 vertex also I will add into my BFS search. Then I will include that also in the Q. Now, at this stage, again, we have to check whether are there any more vertices I have to visit. No, there are no more adjacent vertices 2, 3 other than 1, 6 and 7, among which one is already explored. Remaining are 2, 6 and 7. Now, 6 and 7 are newly visited vertices. Now, since there are no more other vertices, I can say that the vertex 3 is also explored. Okay, now since it is explored, now I will delete it from the queue. So now from queue I have deleted it. So what are the remaining elements? Now I have 4 elements. Since the vertex 4 is the first added into queue among these 4, so I should be exploring 4 first. So from 4, now if I say here from 4, there are 2 vertices, 2 adjacent vertices. Those are the vertex 2 and the vertex 8. Okay, now since 2 is already explored, so no need to bother about this one. So what I should be only considering is that from 4 to 8 as its adjacent vertex. Since 8 is a new vertex which I will be considering, so I will be adding it into my BFS as well as I will be inserting it into my queue. Okay, now from 4 I visited what? 8. Are there anything left out from 4? No, all the adjacent vertices are covered. That means now 4 is what? It is explored. 4 is also explored. Since it is explored, I will remove it from Q. Okay, now what are the remaining? I have 5, I have 6, 7 and 8 as the visited or unexplored vertices. These are visited or unexplored vertices. Now among these one, I have to first consider the vertex number 5 because it is the first Q. So now I will take 5 here. Now from this particular phi, what are the vertices it is been connected to, or what are the adjacent vertices? Those are vertex number 2 and vertex number 8. Okay, now the interesting point here is that 2 is already explored, so no need to consider. The what is remaining? 8. Now, if you look into my queue or if you look into my the BFS, 8 is already visited. Okay, 8 is already visited by which? 4. So again, I no need to visit this 8 because this 8 is already covered in the search from the 4th vertex to 8th vertex. So I can say now that from 5, the vertex 5 is also explored. How it is explored? Because it is connected to 2 adjacent vertices, that is vertex number 2 and vertex number 8. 2 is already covered. See, 2 is already covered over here. What is the second one? 8. So 8 is also covered. It is also visited earlier. So all the vertices which are adjacent to 5 are already visited. So this we can treat 5 as also explored. Since 5 is also explored, what I can do? I can simply remove it from my queue. Okay, then the next vertex is 6. Again 6, there are 2 vertices which are adjacent to vertex number 6, that is vertex 3 and vertex 8. Now again, when we look into my BFS in this particular search, 3 is already covered here. It is already explored. Okay, and what about 8? 8 is already visited. This 8 is also visited. So I can say now that 6 is also explored, because both the vertices which are connected to these two are already visited. So 6 I can call it as an explored and I can remove it from my queue. Okay, then next is what? 7. 7 again here, 7 is connected to how many vertices, adjacent vertices? 2, that is 3 and 8. 3 is also covered, 8 is also covered. So I can call 7 as explored. So I will be removing this 7 from the queue. Then what is left out next? Next is and that is the last one, vertex 8. Now vertex 8, when we see here, vertex is connected to 4 different vertices, that is 4, 5 and 4, 5, 6 and 7. So all these 4 vertices are visited already and are also explored. Then I can say that 8 the vertex 8 is also explored. So I will be removing from this particular queue. So what I have left out in the queue? In the queue, there are no unexplored. There are no unexplored vertices. There are no unexplored vertices. When Q becomes empty, then I can say that from the given graph, I could be able to do the search, and the technique here we used is breadth first search. We went ahead and tried to search in the passion of the breadth first search. We first took care of the one, then we took care of 2 and 3, then we took care of the 4, 5, 6, 7, and then 8. So the breadth wise we could able to search, search in the sense we could able to find out an edge between any two vertices. Okay, like this way the search techniques from the BFS, what we got the result is this particular traversal of the vertices. If I traverse 1 2 3 4 5 6 7 8, then this particular traversal here will give me a result for the breadth first search. So in order to just recollect or revisit the concept here is that we have to start from what? One particular vertex, and that vertex we can call it as an visited vertex. This visited vertex is again, the other term is that it is unexplored as this time, because the adjacent vertices for this particular vertex are not visited. From 1 if I visit to 2 and 3, then I can say that vertex 1 is explored. All the visited or unexplored vertices we need to keep on inserting into the queue. Okay, and we need to continue this particular technique until queue becomes empty. Once queue becomes empty, then we can say that all the vertices are explored. Not only visited, all the vertices are explored. When all the vertices becomes explored, then we get a sequence of vertices. Okay, the sequence of vertices are nothing but the traversal of the vertices. This particular sequence is called as breadth first search list. Okay, is this understood, students? Any doubts? Ajay?
So understood.
Sonam? Any doubts? Anybody has doubts here? Okay, let us try to see the notes, what we have it in the notes. Okay, fine. I will just quickly go through the notes given here. Okay, let me increase the size here. Fine. So breadth first search. In BFS, we start at a vertex P and mark it as visited. Okay, then second step is the vertex phi at this time or at this stage is said to be unexplored, because it is just visited. Its adjacent vertices are not yet explored or not yet visited, so the vertex phi is unexplored. A vertex is said to be explored when the algorithm has visited all the vertices adjacent to it. If we visit all the adjacent vertices to a given vertex, then we can say it as an explored vertex. Okay, consider this as an important for question. You may get a question on what is explored vertex. Okay, so this is important for the point of 2 marks. Then the next is all unvisited vertices adjacent from V are visited next. They are new unexplored vertices. the vertex we now said to be explored, because when we visit all the adjacent vertices from that particular vertex, then we can call that particular vertex V to be an explored vertex. The newly visited vertices that haven't been explored are stored in the queue. Yes, we were storing all the newly visited vertices to the queue. Exploration continues in the manner until no unexplored vertex are left. So this means until the queue becomes empty, we should continue doing these particular steps. Okay, these are the steps that, suppose if you get a question in the exam, explain or write a note on breadth first search with an example. Then you need to write what breadth first search these steps are. Okay, all these steps you need to write, and with one particular example. And the example should be the one which I taught you. Okay, the same example is given in over here. Okay, so what the example, the same graph is there, consisting of 8 vertices and the edges like this. At the beginning, q is taken to be 1, 2 and 3, because these are at the stage are visited. And when at this particular stage, we can say that 1 is the vertex 1 is explored, because 2 and 3 are visited. Okay, so it is removed from the queue here. In this particular step number 1, you will see here that q contains only 2 and 3, and you see a graph with only vertex 1 over here. What it indicates that the vertex 1 is visited, is explored. Okay, and what are the newly visited vertices? Those are 2 and 3, which are adjacent to 1. Okay, then in the next step in the queue, what I have here, 3, 4 and 5. Okay, 5, 3, 4 and 5. I will start from 2 now, and in order from 2, what are the connected vertices? 4 and 5. So I will push, I will add, I will insert it into the queue, 4 and 5. So I will come to know that now 2 is explored. So what I will do, I will delete that 2 from the queue. So queue will contain 3, 4, 5, and I will draw the vertex 2 and join 1 to 2. So here it indicates this particular diagram. What it indicates is that the vertex 1 and the vertex 2 are explored, and unexplored vertices are what? 3, 4 and 5. Among this one, I should be exploring now the vertex 3 in the next time. Okay, so in order to do this one, I will be considering from 3, what are the vertices connected? 6 and 7. So that I will be adding it into my queue, and I come to know that 3 will be explored. So 3 I will remove, and then 3 I will add it to my graph over here. So now the graph will contain 1, 2, 3 as explored, and 4, 5, 6, 7 as unexplored vertices. Okay, then I will continue the same process here. So from 4, okay, from 4 I should, now what I should be doing, I should be exploring 4 first. Okay, so if the 4 is connected to what? It is connected to 8. It is connected to 8. So when I choose it as to be 8, then what will happen here in this particular step, the actually it contains multiple steps. Okay, so here 4, 5 which are connected to 8 are explored, and 5, 6 also will get explored. What will be left out is, the left out one is the vertex 8. Okay, now that you may see over here. Okay, then when 8 is also added to graph, then we can say all the vertices are explored over here. In the resultant graph, it will not be the original graph what you have given in the question. It will be a tree here. Can you tell me what type of tree this is? Anyone? This is a spanning tree. If you notice, the number of vertices are what? Number of vertices here 8, and how many vertex are there? Sorry, how many edges are there? There are one less than the number of vertices. There are 7 edges here. This particular tree, the final tree what we get here, this is the result of the BFS search. Is this particular concept understood, students? Any doubts?
Yes, sir. No, sir.
Okay, let us quickly see the algorithm associated with BFS here. Okay, so the algorithm what we have here is that algorithm BFS. Okay, so here there are different terms or the variables used here, u, v, and w. Okay, now what how it will be worked out is that in order to correlate this one with respect to the example what we have studied. Okay, now in this one I'm using u, v, and w. Okay, u, v, w means here, and there is one more array by the name visited. Okay, this visited is nothing but in this particular example, whatever this BFS is there, this is my visited array. Okay, then I also be using here one more data structure which is called as q. Okay, it is there in the next line q. So that q will be containing all unexplored vertices. Okay, now initially what I will do is that I will start from one particular vertex. Okay, that vertex v. In the example, the vertex 1 I have started, so I will consider the v as visited. So that v I will be adding it into my BFS or the visited vertex or the visited array. Okay, then I should be running through a certain loop statement and which are taken in the repeat until. Okay, in the repeat until again I will be doing a uh, running through a one more loop through the for loop. For what the condition we are specifying here? For all vertices w adjacent from u. All vertices w adjacent from u. So u is what here? It is v. In our example, v was 1. So all the vertices from 1. All the vertices from 1 means 2 and 3. So I should do the steps for 2 as well as to 3. What steps I should do? The steps I should be doing is here. If w, if visited of w is equals to 0, means if that particular is vertex is not visited, if the particular adjacent vertex is not visited, what has to be done? Add w to q. Add w to q means what? I should be adding that vertex to the queue here. Okay, that is 2 and 3. Initially it will start from 1, 2 and 3. Okay, then at the same time add that to visited. Okay, so suppose when I start from 1, 1 will be added to BFS, at the same time it will be added to Q. Okay, it will be added into Q. Next time I will find its neighbor, that is the adjacent 2, that 2 I will add into my visited, and at the same time I will add it into my Q. Okay, and then 3 is there, 3 I will add into my BFS, that is visited array, and also I will add it into Q. Okay, then are there any more left out? There are nothing left out. So I have to repeat it these steps for the next visited vertices until Q is empty. Okay, until Q is empty. So I have to keep on repeating these steps from the Q. Is this particular algorithm understood, students? See, algorithm, you may find it little I'm not sure whether it's complicated or it is very simple. If you understand the steps whatever we have discussed here, then there shouldn't be any problems in understanding this algorithm. Is it understood, students? Any doubts?
No, sir.
Okay, shall we see one more example here? Okay. uh, let us say take one more example from the notes itself. Let me scroll it down. Okay, so is this particular graph visible? A, B, C,
Yes.
D, E, F, G. Okay, and these are the edges connected to it. Okay, now how this particular BFS works on this particular graph, we will see here. Okay, yes. Let me try to annotate on this particular graph here itself. So over here I will be writing the visited vertices, and at the bottom I will be visiting the Q. Okay. So initially I will choose the vertex A. So the vertex A, I am starting with, let me change the color. Mm, 1 second. So I will start from what? The vertex A. Okay. So when I choose from vertex A, I should be adding the vertex A into my Q. Okay. The lower line, bottom line, what I'm writing, this is the Q. This is the Q. Okay. So in the Q, initially what I have A, and in the BFS search, I have A. Okay. Then what are the adjacent vertices which are connected to this? This is, there are D, C, B. I can choose any order. I can choose first B, or I can choose C, or I can choose D also. There is no problem. I can start from D, this end, or I can also start from the other end, whichever is easy for us. Okay, so here I will choose B this time, the other side. So that B, I will add it to my BFS search. So B, I am adding it to BFS search, and at the same time I will add that B into my Q. You have to bear with the this particular tool over here. Okay, B is also added. What is the next adjacent vertex connected to A? It is C. So C also I will add it into the visited array, and also I will add it into my Q. Okay, then next vertex is D. That D also I'm going to add over here. Okay, then I will add it into my Q also. So D is also added. Now at this stage, I can say that the vertex A is explored, because all the adjacent vertices which are from the vertex A are visited now. So I can say the A as explored means I will remove this from the Q. A is now removed. So what is left out? B, C, and D. Now among this B, C, D, which one should be starting with the next? That is the vertex B. So the vertex B I will start now. So from B, what are the connected vertices? A and E. A is already done. So left out is E. So that E I will add it into my visited array, that is BFS search list. And then that the same E I will add it into my Q. Okay. Then next, at this stage, from B, all other vertices, whatever adjacent vertices are there, all are visited. That means I can say B is explored. Since it is explored, I will remove it from Q. Then next is C, I have to choose. So from C, what are the vertices connected? A and E. Okay, A is already covered. E, now you may see here, E is also covered. It is also visited in the previous search from the B. So I can say C also as explored. C is also explored. Then next are from D. So I have to start from D here. So D, A is connected. I have already taken care of the A is done. Then what are the remaining? F and G. So I will add first F into the BFS, and I will add F into the Q. Okay, then after F, the next vertex is G. From D, G is also connected. So I will add that G into the uh, vertex in the visited array, as well as G into the Q. Okay, now we can say that from D, the its adjacent vertices are A, F, and G, and all three are visited. Then I can say that D is also explored. So D I will remove here. Next is what? E. Now E, what are the vertices connected? It is connected to B, it is connected to C, it is connected to F. All these three, B, C and F, are already covered here, or already visited. So I can call F, that is E, as explode. So I will remove it from Q. Next is what? F. F is connected to D, G and E. So D is also visited, E is also visited, and G is also visited. Then I can say this F is now explode. So I will remove it from the Q. Next is again G. So G is connected to the vertex D and F. And both these D and F vertices are visited. So this G is now explode. So now the queue becomes empty. All the visited vertices, or all the unexplored vertices, are now explored. And the whatever the BFS result we got is A, B, C, D, E, F, G. So this is explained in the diagrammatic way or in the notes book here. Okay, step by step the same steps are explained here. So whenever you find this particular diagram, here this is explored and these are its connected vertices. Okay, is this understood, students?
Sir.
Any doubts?
Yes, sir.
Are there any doubts?